and how are people interacting with it, and how are they actually deploying and going things forward. So it's not only just purely from a tool sense, so that you have just all these tools out there to help you do builds and things like that. It's also communicating with your team around how to ship the software and how to get that working. And so there are great benefits to actually doing DevOps. Can I ask actually here in the audience, who has currently a DevOps practice in their company or where they work? So not too many, all right. So there's actually a lot of benefits in doing this. I highly encourage you to listen closely because there's really good benefits in starting to do more of a DevOps approach. You can obviously see there are some really good benefits here, but in my own experience when I worked at, sorry, this is going to happen maybe a few times that it goes black, is that we started out with DevOps very slowly at first. We had a small startup where I worked for before. We did most of the things by hand. When we would do a deploy, we would literally go to the command line, we would type in the deploy, and it would get shipped. Only at the time that really our team started to grow, we started to see like, okay, what did colleagues X do, or the other colleague, and how is this actually going to work together as we start to ship this code, right? Because at some point we had to sort of start to figure out, what did that person, or what is the effect of a certain deployment, and what is the new features that are going to be released. So to get that part of your cycle, it's actually very nice to have tooling and process around that, so that you know from everybody in the team what they're doing, and preferably you don't need to have a certain person of your team there to do the actual deployment all the time, right? Because what if that person gets sick or has an inability to do actually the deployment? You're kind of stuck, right? So you want to have this process automated, and that's really where we started to adopt DevOps, and we really started to see that really make a difference. So even for myself, I wouldn't need to be there all the time on, say, a Friday night to actually do a deploy. We could actually prepare the deployment in advance. We'd have all the tooling around that, and so our deploys would actually be a lot faster, which is really nice. So that brings me then to what are these benefits that you get out of this? Where can it really help? And for us, it was also that flexibility that you see in the first part, so that you actually can choose whichever tool that you want to use. Because if this is a limitation, then you're not going to adopt this, right? You're still going to go back to the command line or whatever tooling that you use to get it working. You really want to have it all in there or not, otherwise it's not going to work. Now the good news is that Azure DevOps actually provides a lot of flexibility there, so you can really bring everything into the system. It's also very fast, so you can actually get good performance benefits out of this by actually doing this. It might actually help to get your team really much faster in rolling out these software updates and working on with the team together. I'm sorry about the flashing. Also, the nice thing that we really liked as well was that this was all open tooling. So we could actually see that some of the deployment tools were open source. This is things where we could actually see how it was put together, so that we can actually also improve our own processes. So this is really nice that this part is working. Now, if you haven't done any DevOps before, these are sort of the pillars to make this working. So the first step is to get continuous integration, and what that means is that you no longer do the build manually, right? So not somebody going into, say, Visual Studio and makes the build, copies the assets over, or other places where you ship software, that you do this manually. Sorry about flashing it. But it is actually automated, so that those builds will happen automatically, and that you also get checks on that, so that you know, hey, is the build actually successful? Is there a problem? And if there is a problem, that the team is made aware of that. That change is huge. If you don't have that now, the moment that you implement this first, you're going to see a lot of benefits in that. And there's a lot of things that you might have to get a bit used to if you haven't done this before. You will need to see that, okay, if there is an issue, we need to follow up on that. Now, maybe in your current organization, this is what, before you do CI, it kind of caters for. If somebody screws up, right, and breaks the build or blocks the deployment, that person usually would get the blame, right? And it could be you. Now, the nice thing with CI is that this is part of the process. It's normal that it breaks. It's actually nice to know that it breaks, because now the team can actually go forward on it and say, okay, let's fix this, right? And that everybody is on top of it, and that it's a team effort to actually keep this working. which is really nice. So that's the first thing. Once you have that in place, once you know you can get these stable builds and it's actually working, and you know your team is all on top of it, and you go like, okay, we can actually start now shipping these things. You might still do it manually, but the next step would be to actually start to automate that as well. And this is what continuous deployment is around. So that once you have these automated builds, it already gets prepared. And we're going to see some examples of that actually later on how that actually would work in terms of pipelines. And then once you're there, that's all this tooling what I talked about before. And again, going back at Microsoft's definition of DevOps, it also means that you know how the process works together. So once you do a deploy, and it's out there in the wild, is it actually working better? Do you know it's performing well? Do you have tooling to get all these metrics together and pull it together with the build that you just shipped? And that's what the continuous learning and monitoring offers, so that you have the whole cycle complete. So Azure DevOps. These are the actual services in there. If you used to Visual Studio Team services, there's a few familiar ones in there, but you might also see some new ones. And these pillars are really where it's now built on. You see these as different services. It's no longer feeling as a whole as it was with VSTS before. You now have actually these several separated services, and we could actually use them independently if you want to. I think that's a big change that I see with this changeover. Before, VSTS would feel as one huge thing that you need to adopt. Now I think with these silos better indicated, you actually can see that you could actually start out with some of them first, and then knowing that you could actually expand it further and get more into it is actually nice to know. So that's the other thing that I want to take home, that in the change now, what we see with this release is that pipelines is a big thing now. That's much more an isolated thing and better highlight. And it really helps you to ship your code. But it's not only specifically to, say, a Microsoft environment. It's really made now for actually running for many other environments. So you can actually target much better for other platforms. There's build agents for that to actually help you deploy to other platforms, say macOS, Linux. And you can even deploy to containers as well. And where's Davide? Is he around? I don't see him at the moment. I think he's, there, in the back. I think you're going to show something on the Kubernetes, right? On how to do deployment there. So that's going to be real interesting to see, because that's fairly new into it. And it's also great that this is all open source, so that actually it's all developed out in the open. It also means it integrates well with your other open source tools. And that actually brings me to this part, which is a different Microsoft that I'm seeing a lot. It's a lot more adoption of open source. So if you actually see what contributions have been happening over time, is that you see there is a lot more happening, especially related to open source. And I'm not sure if this one is in there. It was maybe a still fairly recent announcement. Where a lot of the patents have been actually brought under the Open Source Foundation. I think it's called the Foundation. So that actually, it's really showing that there is a good commitment from Microsoft to actually help these open source projects to thrive. Because you can see the tooling is also really built upon it. So fostering that is really great. So then to pipelines, you can actually see here really that one of the bigger changes is that if you do any open source projects, anybody makes their own open source project? Davide in the back? Yeah, okay, few of you. Okay, so you know that if you make your own projects and you need to test whether the things work, you have built solutions for that. Now you can actually use Azure pipelines for that, and it's completely free. You can actually use the infrastructure to build all your projects, and you can use it even across different target OSs. So really have a look into that if that's what you do now. Another thing to sort of reinforce that statement is that there is really good integration also with GitHub. So you can integrate this into your project. It means that when you do a check-in, it will automatically detect that a new build should happen, and you can actually see, for instance, in your pull requests that the build is happening for that pull request, just like you have seen maybe for other CI integration as well. And so that again leverages that free infrastructure that you can use for this. So back to the DevOps part. Let's see, we're gonna go individually into the different services now. So Azure Boards, sorry, where is it? There you go. Azure Boards is like a planning tool. I've been using this a lot in my previous company, and it's been really nice to use this. It really nicely ties in as well with your code base. So especially for software development, this works really well. But I think it's also very friendly and usable for other team members to actually work around Scrum planning and task management and getting a scheduling for your product. And to demonstrate that, let me just go to actually the Azure DevOps and practice. So I have here my own account. You can see, is it by the way big enough for everybody to see? Yeah, all good? Okay. So you can see I have here in my organization a demo project. So I generated this one, which has most of the services in there. And the one that we're going to look at, so if I go into here, oh, no internet, that's not good. Internet here. Yeah, the guest one. Yep. All right. Does it connect automatically straight away? Autocomplete, please. All right. Yep, there we are. Okay. Sorry for that, and thank you for waiting. So this is the project that I just went into. It's a demo project, and what I wanted to show you is the boards feature. So this is where I can see my work items. So these have been generated, and this would help me, for instance, to see what I need to do during this week, what I need to work on, and see what other people have maybe planned into it. I actually used to do this a lot with my own team. We would start out the sprint where we would look at, okay, which are the things that we need to work on. And so when we would do that, actually, we'd go, expand this so you can easily see it, to the backlogs. Because these are all features that we would actually work on. So if we go into one of these backlogs, here you can see the features that we plan to actually work on. And we would be able to, from a high level and lower level, see how they are structured into higher level features. Product backlog items is really the items that you would work on, and then individual tasks and bugs as well that are related to that as we would continue to work on that. And in terms of planning, we would actually be easily able to drag and drop this into the diverse sprints. And so we have this nice planning tool that we could actually look at with the whole team in the beginning of the sprint. And okay, what do we actually want to do? How do we want to build it? Have good collaboration around it. Everybody can add the tasks that they're going to work on. And it really helped to plan the features for us. So if we look at then at the sprint structuring, let me go to the backlog. Then you can see here for the current sprint, these are the items that I would actually work on. I can also remove the planning so you see a bit more details. So here you could see, for instance, the other team members that would work on this. And you can even subdivide this into other groups. So in our company before, we'd have, for instance, a front-end team, a back-end team, a business team in the middle, and they would all have their own group and would be able to plan it independently. But you can also put it all together if your team is smaller. But this is really built for like large and small teams together. The other thing that we would then also would use, which was a really nice visual tool, is the Kanban board. So on this high level, you can see that that you have these items on the side. Who knows here what Kanban is and how it works? Yeah, a few. So it's like the model. I think it was Toyota who came up with it, where they actually move these. Think of it as sticky notes in motion. So you get a better feel of how your projects are progressing throughout the sprint. So you want to see everything at the end and done, and you can see also what's happening in the middle. And if there's too much happening, you get a good visual view of that. Now I'm currently looking at the features view, but you would also, for instance, look at more detailed level on these things that you'll be working on. And the whole team would be able to see what is in progress. And this graph, because it's a demo one, it doesn't really represent it well currently, but you would actually see an inclined line over time. And you would actually see if you're kind of under or above the velocity that you would want to be at. These things are also nice to categorize. You can really drill quite deep in how this is actually structured. There's also query function, so in case some of the views are not what you wanted, something that we encountered, for instance, we had different customers, and the way how we could actually make it work, I don't have this in the demo project here, but in the previous company we would have tags on these individual cards, and then we simply query by tag, and then you see all the things for instance, a specific customer, because we had multiple customers at that time. All right, so that's the overview of the Azure boards. The next one is repos. So repos is essentially a Git repos, also TFS, and this is where all your source code can live. Of course, you could also use, say, GitHub to host your source code or another repository provider, but the point is that you could also use it together with Azure DevOps and combine the two things together. In fact, if you would look at the task board, you could even, in the task board, when you create a new task, create a new branch automatically, say in your source repo, and as you would complete the pull request, this would actually, for instance, complete a task on the planning board. This is actually something that we used to do a lot, and it really helped to automate that part on planning and actually working with the code. So that's what I want to show you now a little bit, what that looks like. So if we go here, where's my mouse? Do you see the mouse? I don't see a mouse. That's new. Can we get a mouse? This one. Okay.
Bart, just a
yes,
question. Do you
yes.
know, like, for the repo, like, do you know what the cost of that is?
That's actually free.
Actually?
I think it's free. Yeah.
Okay, which is great because, like, GitHub private repos are like it cost. So I assume these ones are.
Yes.
They're not.
Yeah.
They're private.
It's by the number of people using it, and I have a pricing tab later, so I think it shows there the better details on the exact pricing. But yes, it is, I believe, free for teams under 5 people. And then you eventually get like a payment model per user using that. So similar, like if you use things like Office 365 or those kind of products. So again, in this demo project, it generated everything under me. So that's how that worked here. You can see, for instance, also the files. So this is just the file structure like you have normally. This one I've been actually finding to be very useful, especially if you just normally have Git access and you need to quickly jump back in time. So you can dive into your projects. You can see which pull requests created. So it's a nice visual explorer to go there. You also can see the commits, the activities that are happening there. You can also have multiple repositories where you store it in. It doesn't need to be just one. It can be multiple. So here you can see like a typical commit history as well. You can also see the branches, and that's what we would use a lot when we actually create different features. You would see actually it branch out. Unfortunately, there's not one in here. And we would also have here, say, the pull requests. Now, you can see there's also some comments in here. Currently, they're the same. There's supposed to be a different user in the demo. But how it could work is that actually if you see the files that are, for instance, edited, and I really like actually this view that Visual Studio has, and we've been using that a lot when we do quick reviews, is you can see a very nice change view. Let me see this other pull request because I think it looked much nicer in that one. I think I picked the first one. Yes, okay. So here you see, for instance, multiple files that have been edited. This one is new, so it's plus. Oh. Yeah, okay. Oh, I thought there was a different one that looked different. Okay. sorry, if I go back to files, what you can do actually is on file level leave comments. So I can, for instance, list it out here. That actually goes back into the pull request. Very similar that you used to GitHub. So it's actually pretty feature complete like that as well. So if you don't want to use GitHub open, you can also actually use this one to host it internally. But again, as I said, if you want to swap out these things, that's okay. That's how you can use it. I've been finding this very useful as we could actually tie this in as well to tasks. So we could actually see on the planning board if people would leave comments. We also have the code review process here, so that only once the pull requests are reviewed, it's actually going to be merged in. All right. Any questions so far on this this part? All good. Okay. Let's go back here then. So test plans, this actually allows you to do testing for your software. I don't have a demo on this one, and I haven't been using this one in my past work, so I don't have too much to show on it. But this would actually allow you to run tests on your software, know if it's regressed. You can integrate it together with the other services like pipelines, so it could pull from your source codes after you do an update, you get builds, you then have automated tests, and it will then tell you, the results of that. So then again, back to that whole loop, bringing people together, knowing that something works, something is actually in process. That's what you want to know to get the whole the circle complete. Artifacts, that's the next thing I want to discuss, and this is new. We haven't been using this one before, but I'm quite excited about this one, because what this means is that if you have dependencies on packages, say npm or NuGet, or for Java you have Gradle and Maven, you can actually get these package sources in the cloud here as well. And what that means, the benefit is that you actually get your own packages in there as well. You don't need to publish them publicly to everyone. This is a private package source. And you can also make it so that there is an upstream source, so that actually when you try to get the public packages, you actually get it through your own stream. And as you've done the build before, it will cache that in there, so you don't have that dependency on the network, which we all know can happen, when it goes down or it's slower. And if that would stop your build, that would be quite a serious issue. So being able to depend on your own package source for this, it's really nice. And another new thing that I noticed, which I thought is actually quite nice, I will try to do it without my mouse, is that you can actually now make your own packages. So this package that you see here is me just running a command line on the VSTS command line, and it picked up all the files that were in the directory and put it into a package. So this could be great if you just want to deploy something quickly, that you have maybe some standard template or something like that, and you just want to get it in the folder. You can just run one command, it downloads it from the package repo as well, and you get it on your machine. This is still in preview, but I think this is quite a nice feature to actually do some packaging for your own code. All right, so with that, we have seen now all the different services. And again, as I said before, you can see they can complement each other really well, but you can also maybe see in your own current organization that you may already have some other services that you use for that. And that's not a problem. You actually can nicely mix and match this together. That's really the difference now with Azure DevOps. They all have their own strengths. Maybe you're already using it or heavily invested in it, and it would be a big deal to switch over completely. You can actually work together with these other services. And as you can see, it also nicely integrates with other Azure services, especially if you talk about deployments, and that's what we're going to see later in the demos. So with that, there's a lot of nice features and availability on this. I've been having really good experiences with that in our previous company and doing these builds. That was really nice. We actually, could actually really rely on these tools. There's been, as I said before, times that, where I had to come in on a Friday to actually do the deployment. That was at some point no longer the case. We could actually have all these things done automatically, tested for us. We knew if it will be good. We know with much more confidence that it's actually ready to ship, and then we would actually ship it also automatically through the release process with its own tests on it as well. And that really made for the whole team a whole lot more solid. And knowing that we can cover this whole spectrum here, that really makes it very complete. So pricing, that's what was mentioned before. So for open source projects, you can use this for free, up to 10 parallel jobs. So to actually build that, unlimited minutes. I think there was a different build service before, which had limitation on the number of minutes that you could use. So that's now unlimited. That's really great if you have that open source project. Also for small teams, again, up to 5 users, you can start out for free. And after that, you get per user this fee. But if I recall, the amount of time that we saved with this, and just in general how the team was feeling so much better about it, this is kind of priceless to us. And with that, that's yes.
No Azure for open source.
I think it's also included. Yeah, I'm not 100% sure. I can check that for you later. But I think it's included. All right, and that's it. Thank you, everyone. If there are questions, I will take them now, and in the meantime, I will let Steven set up his machine over here.
What's the long-term plan for GitHub? So it's overlap, right? They're merging, are they?
I wouldn't know. Sorry? Oh, sorry, yeah. So the question was, what is the long-term plan for GitHub, right? What do they plan to do with it? I think it will still be around. You can see that integration-wise, it's really meant for integration.
I think I can take that. So the long-term plan for GitHub is everything remains as is with the enterprise support. So GitHub is still independent. I mean, GitHub is being acquired by Microsoft, but it still has its own CEO, its own independent board, and the very long-term plan is that everything remains as is, two different entities, so you don't have to be scared of anything. But it's going to be better because it's going to be fully integrated with Azure DevOps and other tools, and on the back we'll have the full support, the full enterprise support from Microsoft, which didn't have before.
Yeah, thank you for jumping in there. Any other question?
How it coexists with VSTS? Is it still there as a separate thing, or?
Yeah, I didn't go too much in depth because in my current project I haven't been using it so much as of late. So what I did see is that there is a transition period, so you can still use at the moment the original VSTS, so that you actually can switch over to the pipelines as well, and that is currently still an opt-in. But I think in the long run, I don't know the exact date, but it will then switch over to Azure DevOps. So I would recommend that you start looking into the transition, but it brings some nice benefits to it.
I guess it's the last time David presented the VSTS, and yes, it's just moved out.
Yep. Cool. Any other question? All right. All good. Okay, then I'll hand it over to Steven.
Thank you.
All right. Okay. So okay. When I started development, maybe a decade or so, 10, 12 years ago, I used to do a lot of build and deployment, that kind of stuff, even before there's a term for DevOps, and I found that it's for my software development career, it's been really great for me because it really taught me that if it works on my PC, it doesn't mean it really works until you actually deploy it onto your customers' users' machines. It's taught me to to write better code to make sure that all environments are covered, so that it's not just just on your machine, it works well. So I spent a lot of time doing build and stuff, and back in the days, did a lot of cruise control, NAND, MS build, install shield, that kind of thing. Tools is essential for DevOps, and during this whole during this decade, there are many tools that come and go, but I think I'm happy to say that after using Azure apps DevOps for around 2 years or so now, I think it's here to stay. I think it's a pretty good tool for doing build and deployment. So for my presentation today, I'm not going to go my focus is more on the build and the release side of things. But I'm not going to go through the features one by one in the slide. I'm going to dive down into a project that we use Azure DevOps in. I'm just going to explain what we do. So I'll talk a little bit about our project, and then talk about how we use it to deploy on app services on Azure, doing mobile apps, and also we have like a pipeline to do to build like machine learning models as well too. I'll also give up some tips and other experiences that I have as well too. So the app that we created was actually for the airport taxi, and so if you've been to airport, you've seen these like mega long lineups in the airport. So during its peak time, like there would be like easily like 400 or 500 taxis that would be waiting here. And one of the problems that they want to solve is that often the taxi drivers they're not going to stay in the car because it's usually going to be the worst kinds of waits are an hour, 2 hour long. So they usually go out, stretch out, go to the washroom, take a break, lunch, and all that kind of stuff. And when their number gets called, usually it's by line. So when their line gets called, they want to, sometimes the taxi drivers don't come back in time because they don't really know they don't know when they should come back, because it could vary depending on the time of the day, how many arrival flights there are. And so we helped them build an app that would tell the taxi drivers what sequence there are in the queue. So in this case, like they're the 40th taxi, and this number will keep going down as more taxis leave the area, and so on. And so this will allow them to kind of gauge like what time they should really come back. We also show, like this is all Chinese, but we also show we have a machine learning model where we actually estimate how much time their wait time is going to be. And so and as this time sort of comes down to like 5 minutes, and so we'll send out a push notification to tell them to come back, and because if they don't come back, then they're going to get blacklisted and they won't be able to return to the airport for further customers. So we have a mobile side to our project. There's also like a web front end, which hooks on. This is really the admin console for our website, where we hook up to our database and do a lot of CRUD related stuff, managing users, taxis, do blacklisting, that kind of stuff. So there's the mobile side, and there's also the and this is all written in ASP.NET Web API. And it's hosted on and it's deployed on Azure App Services. So as I say, like we have 3 components. So the mobile side, the web on apps on Azure App Services, and we also have the machine learning model, which was what I was talking about, the estimated wait time. And this model is built on AWS on an EC2 instance. And I'll talk a little bit more about that later. So I'm just going to go through each part and show you guys how we actually do the build and deployment for them. So the admin console side, as I say, C#, ASP.NET Web API. Front end, we use React.js. Database, we connect to MySQL, which is hosted on AWS. The build, we mostly use PowerShell and MS Build, and then deployed on Azure App Service. Okay. Let's see if this opens up. Okay. So back to Azure DevOps and pipelines. So under pipelines, you see they separate the categories into the build and release, and a lot of the older tools that I used to use doesn't really have that kind of concept where it's like the build is separated from the releases. But this is actually a good idea, because often the build should really be a little separated from the releases, because you make a good build and then you might deploy it to different kinds of environments. So to a dev environment, to a QA environment, you might have staging and production environments as well too, but you still all use the same build. That's how you know that, okay, when I fully test on QA, it's ready to be pushed out. So I'll talk about the build first, okay? And here I have a couple of projects I mentioned before. So I have that first one up there. That is for building the admin console. The prediction training model. That's the ML model that we have and the mobile side. So first thing is like when you get to the dashboard, you see all the kinds of histories that you have. They'll show you the build number, whether it was successful or not. You can even lock the build itself so that it won't get archived or deleted later on. Let me jump into, so each one of this. So the input to a build is usually your source. So whether it's from GitHub or from Azure Repos, from other places, you pull in your source codes, and then the output is an artifact that usually it's say like a zip file containing the binaries and all the files that you need to actually do deployment for. So let me show you, for example, here. So this is for the admin console that I was talking about just now. So the first thing with pipelines that you would have to choose. So I'm going to just start from the bottom and go down. The first thing that you have to really decide is the concept of agents. So you have to build something, which means you need to do compilation. You need to gather all the binaries, put it into some nice folders, maybe zip it up, do some kind of transformation. But doing all that process, you have to do it like on a machine somewhere, right? So you have a choice of doing it on Azure on Azure DevOps itself, okay, which is what they call the Microsoft self-hosted machine, or you can do it on your own self-hosted machine in your basement, for example. And this too is a very important. They have very important difference. I'll talk a little bit more about it when you want to choose one or the other. So in my case, all my projects are built with a self-host machine that is in our company. It brings a lot of benefit for customization and stuff like that. So I'll talk to you more about that. In the dropdown, the default is the name of my very well-named PC in our basement. But see here, you can. These are all hosted instances from Microsoft. So, and you can see there are. You can build it on a Linux instance, on Mac OS, Ubuntu. So each environment has your own set of toolings. So for example, if you want to build a .NET application, you're not going to choose a Mac OS host, and vice versa. If you want to build like a iOS app, and so on. So this is where you choose all that stuff. Next, as I said, the input is always your source code, so you can choose from all these different kinds of source code repositories. And under here, you can choose your the branch that you have. And there are other options that would be handy when you run your own pipeline. And then on here, these are all the tasks that you would run to get your build up and running. So it will start. So on the machine, on your agent, it will run from top to bottom. So in here, I have a PowerShell script that I use to actually trigger the Visual Studio builds. I would put it into a zip file. I would share it, and then I'll publish it out for deployment. So So I'm not gonna dive down too much about it. Let's see what else. So if you want to do continuous integration, the trigger here you can enable continuous integration here, which means that whenever you commit anything into your repository of choosing, it would trigger a build automatically, which is what you want to do, because you don't want to be building when you need the build like the most, just before something fails. And so this is where you do continuous integration. You can also add scheduling if you don't want to do that. so the time of the day, when you want to do it. I want to mention that Microsoft been doing a good job with Azure DevOps, or before it was Visual Studio Team Services, because it has always like they keep investing and putting out new features. Because in the past here, like I won't be able to choose like exactly what day to do it. I would have to do a lot of do a lot of clicking to actually do this kind of stuff. But anyway, that's my side rant about how how well how they're actually investing a lot into this tool. So yes, you can do scheduling, which is great. So I'm just gonna trigger this build. This build, by the way, it takes 10 minutes, so I'm gonna spare you the time. But I'm just gonna trigger it first and just show you what it actually looks like. So right now, it's been queued to the PC that's in our company right now, and I can go inside and see the actual real-time status of what it's doing.
Does this go directly to production?
Oh wait! Oh, it got me there.
I have a question.
Yeah.
You need to open up any firewall or anything to actually make Azure to connect to your.
I don't remember doing it. I thought it's just on like 443. Like I think it's just HTTP, TS, and yeah, I don't remember setting up much firewall.
You should have a kind of an agent running on that server,
Yes,
right?
yes. So there's a process. Yeah. So Windows Service actually on that machine. Yeah.
Yeah, sorry. The connection is initiated by the host you have on-prem. So it can pull in and then it pulls the source code.
Oh, so it pulls. It pulls instead of okay. So it's not pushed by. Okay. Cool.
Steven,
Yep.
a quick question. I tried to set it up in Azure directly, but I cannot deal with C# version 7.3. Gave me an error. I could only go up to 7.0.
Is it the? Could it be just like you're talking about like a hosted environment, right?
That was Azure App Service, trying just to deploy automatically from a master branch, staging branch, into app services on Azure.
So if we're talking about the C# version, we should not matter because then you don't deploy the C#, you deploy the compiled binaries that is not dependent of the version of C# you use. If you're talking about build, then depends on the host agent you choose. If you choose the host with Visual Studio 2017, they should support directly the latest feature.
No, that was not in DevOps, that was directly in on the Azure portal, like with the Project Kudo, what it's called, where it pulls directly from GitHub and builds on Azure.
So could it just be like a different like a .NET? I'm not sure what the latest .NET framework version is on App Service. I would imagine they would have the latest on Azure. So App Service. Yeah.
It takes a couple of weeks to have the latest frameworks deployed on the whole fleet of app services worldwide.
But 7.3 is older, it's not that new.
When did you try it?
2 weeks ago.
Maybe you can follow up later.
Yeah.
And they gave me the error message. It really tells you the only valid version is default and 7, 6 or 7.
Really. That's weird. Like they should need to know like what C#.
I thought it would be the same as here in DevOps.
Yeah. Okay. Anyway, back to here. So, so you saw that like all that text like popping up here and there. So it's real time like where this is what the agent is actually doing at the back. It's running my scripts. I'm getting NuGet packages. I'm compiling, like building my React.js stuff, and then soon it will be, it will go like it will archive and do all that stuff. But what I wanted to show you was like just like that you can see it real time, where it's at, and like how long it took and so on. You can go back and see how the previous task went. And so on. So it's pretty nice to see all this in real time. But I'm going to jump to so I'm not gonna just stand here for 10 minutes to wait for this build, but I'll show you one that is completed. So once it completes, you have a summary of. You can see where this commit is made from. So you can see the actual SHA from our GitHub from our Git commit. The archive that it produced, you can download it if you want to, and whether it got actually eventually deployed to our machines. And I believe this one will, because we do continuous deployment as well onto our dev servers. Not our production, though.
Stephen, do you also do like tests as part of the build pipeline?
Yeah, we haven't really leveraged like automated test in our project, so no. But imagine it'd be pretty simple to set up.
Just one question, right?
Mm-hmm.
Kind of choosing automatically what will to go for your QA environment, your staging environment, or your production environment by the tags, or kind of you have a build, you tag it with one environment,
Mm-hmm.
and it automatically goes and deploys to that environment. Is that kind of is like
I see David wants to
Yes.
answer that.
I don't have that in my demo later, but in my demo I'll have something that is called gates. So the gates can be configured for different in different way. It can be some test, can be some HTTP call, or can be some tags. This is I don't as I said, I don't have it in my demo, but we do that internally in Microsoft. So it's only some of the release are targeted for production, and they're the tags.
Okay. I'm just gonna speed up my presentation because I think we're out of time. We'll be out of time soon. So that's no. We have a lot of great questions.
I
So
have a question for you.
okay.
There's any reason why you decided to go for CI using PowerShell instead of using the tasks of the build itself?
Like I find for myself, I find it easier to control. I know exactly what it's doing and stuff like that. So throughout my career, I've always sort of wanted to do it kind of nitty gritty. And plus, I can do it on my own environment as well too, as well as on my devs as well. So I know that if it works on my PC, it should work on the up there as well too. Yeah, so that's one of the reasons why.
Steve, you still have like 10 minutes.
Oh goodness. Good. So on the release side, so you see I have different environments to do my release. I have different, so you can actually choose to do your releases all under one pipeline. So here I can add one more for QA, one more for staging and so on. But I find it useful to separate it out because say for example, for the dev, I want to do continuous deployment, but QA, I want to do it scheduled. And for staging and production, I actually have pre-approvals before I actually deploy it out. So the different configurations that I use for that. So just jump into, so the artifacts I choose from the build side. So that's that. Under here, I can choose whether I deploy this automatically or not. And then, so on here as well, you can choose to manually deploy the release subsequently. There are, as David says, there are gates. You can do, I believe I just read this through, but you can hook it onto some APIs, for example, to see if certain criteria are met or not. There are pre-deployment approvals where, so for example, my manager has to approve before it goes to production and so on. That's all done here. The actual pipeline itself looks just like the build side, where you can choose, you can unzip stuff, you can deploy to Azure App Services. and so on. So that's the release side. Um, I'm gonna skip through some of this stuff. So just wanted to quickly talk about, so on the mobile app side, so we built this with React Native, and then we built it on also our self-hosted Mac Mini in our company with Xcode, and then we deploy it to the IPA to Azure Blob, where we'll take it and upload it to Apple Store. So that's just a remark to tell you that, okay, this is not just like a Microsoft tool. You can build stuff on Mac as well too, which is handy, especially if you don't have a Mac yourself. You can just trigger one from an agent that they provide as well too. So that's handy. One of the last things I wanted to show is that we have a we built our machine learning model as well too, and I just wanted to show you that again. This is not just a Microsoft thing, and we're playing well with like all like AWS and so on as well too, because so for this, when I started the project, I don't think Azure actually had a deep learning kind of like an image virtual machine that we can use. So we went with AWS, and all these kinds of steps here. We would create a AWS virtual machine, and then deploy our Python code to it, and just do like a basic linear regression on it, and get the model back, and upload it to our app service on Azure. So all this is done, can be done on DevOps as well too. So that's the part that I want to talk about for the machine learning. Let's go back to here. So good time. Okay. So this is just the machine learning model. Not going to talk too much about it. So some other cute stuff as well too. So it integrates well with Slack. We use Slack a lot, and so every time there is a build or a release that goes on, you can actually see it on your Git channel. Just really handy. It integrates well with a lot of other services as well too. I've never used a lot of these tools, but I'm sure it plays well with them. So just now I was talking about like Microsoft versus self-hosted agents. So you generally want to self-host, put it on your own computer, on your own PC. If you are quite sadistic like us, that you want to do all the work by yourself, because it's actually a lot of work. So you have to, of course, provide your own PC, you install your agents, do all the setup. But the reward that you get out of is that it's fully customizable, because the standard host that you get from Microsoft, they're great. They have a lot of tools on there. You know, all the Visual Studio, the nodes, I'm not sure if Python's on there, but like a lot of the tools you can actually find on the host, on the hosted one itself too. But say like we want to control like every little bit of like our build process, then you would want to have a self-hosted environment. The other thing that I find is that it tends to be quite hard to troubleshoot a problem if it's on a hosted environment, because you can't really go into the environment, RDP, like a remote desktop into it, or open up a console, PowerShell remote into it or so on, to check out what the actual issue is. You can't see the logs and stuff like that. You don't know what kind of code is actually running. But with a self-hosted one, I can actually go deep into even just a line of code that is running and be able to debug sometimes what the problem with the build is. It's good to mention that the agents, they will self-update themselves whenever there's a new release, which is a blessing and a curse, because sometimes there would be bugs, and it will break a build as well too. And that is where the troubleshooting part is good that comes in because you'll be able to go into the code and see, and sometimes even mess with their code. You can you can change your code and then to do whatever you want to do with it. So there's also the talk about the cost as well too, because I think in over a long run, self-hosted might be cheaper if you do a lot of builds, especially if you do continuous integration and deployment. You'd be, in a very active team, you'd be running that build like 24/7. You really want to, you really want to milk it. And this is where I transition over to talk about the costs, right? So there are two types of costs based on whether it's Microsoft hosted or is self-hosted. So with Microsoft hosted, it's free up to 1,800 minutes. So if you kind of count, right? So say our build, it takes like around 10 minutes to build, right? Not very impressive, but 10 minutes to build and then maybe 5 minutes to deploy. So during a month, like if I have to, like if you count it, like I really won't have like a lot of free minutes to use. So, but with a self-hosted job, you can do as many as you want. So that's where, okay, if you're just building for like a really small project and just for yourself, building just once a day, then Microsoft hosted that's perfectly makes sense. But if you run a lot of builds, then maybe self-hosted makes more sense. The also thing about like parallel jobs as well too. If you pay for more agents, you can run things side by side, which is great because especially if you have multiple projects. So we have like 3-4 pod projects on Visual Studio on Azure DevOps, and we would come across a problem where one project is building and the other one is waiting for that same agent to run that, and so we'd end up not having enough agents to. People would be, complaining, why is it so slow? Who's blocking my builds? So that's where you want to get like a pay your dough and then go for more parallel jobs. Okay.
I mean, you should. I just want to check that you should have control to stop the running build and.
Yes, totally. Yes. Just through the dashboard, you can just stop it whenever you want.
Question here. Since Microsoft hosted is a platform service, right? And in the self-hosted, you have to monitor or
Yes.
secure the uptime for the
Yes.
hosted entity. Has there been any issues there?
For us, it's okay because we haven't had much trouble with our servers. We built our server with keeping it up like a 24/7 in mind, and so we haven't really need to maintain it much. But as you say, like you have to do the patches and all that stuff. You have to, think about that. So for us, we're just a 20 man company. Maybe it makes sense for us, but when it go to enterprises, you have to have like many of these machines. I'm not sure if it would make sense. So I think it's different for every use case. Okay. Some other quick tips. The actual website that you saw, is hosted depending on how you select it. So recently you're able to host. So I'm talking about the actual dashboard, like the site in Hong Kong. Because before, for the longest time, we've been hosted in US East. So there's just very little, I guess, latency or lag whenever we try to do stuff. So, and then we got approached by Microsoft saying, hey, you can actually move it to Hong Kong. So we actually migrated to that, and it's been just a little bit faster, which is great. As I said before, Microsoft is investing in this. I see continuous improvements on this, every single year that I use it, which is great. A lot of the tasks that you saw, with building on AWS or the PowerShells and all that kind of tasks are all open source, so you can actually go in and see the source code yourself. And if you wonder why it broke, you can take a peek at that. So for my own experience, DevOps is not easy. Been doing it for a long time, but it's something that you would want to. If you do it, it's something that you have to really plan for it and spend the resource on it. Because one of the thing is, I find writing build automation code even harder, sometimes even harder than writing production code, because it needs to be absolutely solid. Because if this is going to be used like across teams or across many of your team members, if something breaks or something is slow, there's going to be a lot of complaint, and people are going to lose confidence. Like, is this really going to deploy well? Is this going to help and stuff? So my advice for doing DevOps is you need to find someone that is, too good at it, or be planning. Like, you need to be prepared to learn a lot from it. So DevOps. Oh, so like a lot of the automation code. So even like for itself, like we write. So I write a lot of the PowerShell, like the build code, for example. Release sometimes you have, depending on what you need to do. But the whole pipeline needs to be solid. You need to test it out, treat it just like production code. Okay, with that being said, any quick questions? And I'll let David do set up here.
So you have the database in AWS, you have the front end in Azure, and you build your own.
Yes. Yeah.
Is there any lag?
No, not really. So if we're talking about like, so I guess MySQL to Azure, like for our use case, like it's really like a really like CRUD-based app, and at one time, like we have maybe like thousands of users at the same time. It's not really a heavy load on our system. Like we don't have a lot of big queries, so.
Like the information in the app for the text drivers,
I guess there'll be lag a little bit, but that's something that's part of our SLA. We're not going to be like stock takers, like refreshing every millisecond, and so for our use case, we didn't need anything that is very low latency. I think first step is to start to just make a build scripts for your product, something that you can run on your own machine, that would work not just on your machine but also in other developers' machine. That already saves you a lot of time, I'm sure, because everyone will have their environments, and the things will break, but you don't know why. So getting that just solid and making sure it works every time. That's a first start, and then you slowly build up to do these things.
That's how you also did with your own scripts, right? You have your own.
Yeah, I'm just more a control freak for myself. Yeah.
On the other hand, I'm very lazy, so I use all the ready-made stuff.
Which is good. I don't want to reinvent the old wheel. Yeah. Okay.
You can deploy to AWS, right?
Yeah.
Like even you can deploy the front end to
Yeah, you can.
Firebase or any other kind of
Yep.
medium.
Yep. Okay.
Okay. I think that's all sorry. I think that's all the time we have.
Okay.
So
Yeah.
you can ask afterwards, Stephen.
Yep. Okay. Thanks, guys.
All right, I jump in straight away. My name is Davide, but you can call me David or whoever you like. I'm a global cloud solution architect in Microsoft here in Hong Kong. I used to be MVP for Visual Studio Application Lifecycle Management, which then has been called DevOps. I'm an MMA fighter. I'm a founder of the Hong Kong community, and I'm a staff member of .NET Toscana in Italy. So today, I have a few cool stuff, I guess. So I will talk about doing release against AKS, so Kubernetes cluster, and against serverless, so Azure Functions. Before jumping in that, I will spend just a few words on what AKS is and what Azure Function is. Some CI/CD gotchas and lesson learned, and then I have the demos. I have just a few slides. So if you don't know about AKS, or if you don't know about containers in Azure, you probably imagine that we have multiple ways to deploy containers and to run containers in Azure. AKS is the fully managed Kubernetes services that we have, which, by the way, is 100% upstream Kubernetes. So it's not a Microsoft implementation of Kubernetes. It's 100% upstream Kubernetes, and it's fully managed. What it means is that in a normal Kubernetes cluster, this is a situation. You have few head nodes that you need to maintain yourself, and you have some agent nodes that you still need to maintain yourself. With AKS, first of all, you remove all the work you have to do on the head nodes, because all the head nodes are completely fully managed by Microsoft, and you don't pay for that. So in this situation, let's say you have 8 node VM, 3 master VMs, so you pay for 11 VMs. In this situation, in AKS, you only pay for 8 worker nodes. You don't pay anything for the masters. They are fully managed, and also the agent VMs are almost fully managed, are still VMs you can log into, you can do your stuff, but we manage that for you. So this is AKS. It's a fully managed Kubernetes cluster in Azure. Azure Functions, on the other hand, is totally serverless. You just deploy your code, you run your code in there. You don't have to care about how much CPU you need, how much RAM you need, how much resources you need. We scale for you automatically. You can put some boundaries, of course. We don't scale unlimitedly if you don't want to. And there's kind of reduced DevOps, but not for the DevOps that count. So you still can do and probably want to do real DevOps, meaning all the CI/CD stuff, all the upgrade management, etc. But you don't have to care about all the operations on the VMs, on the servers, on the hardware. You can develop in any code you want. We support Bash, Batch, C#, F#, Java, etc., Python, and it's fully integrated with all the other Azure ecosystem and also third-party services like, if you see, Twilio, Box, Dropbox, etc. So this is just a very subset of what we have. There are hundreds of services that are integrated with Azure Functions. So before jumping in the demo, since I normally put this part at the end, but since I don't have much time, I want really to give this first, so you will know that, and then we go into the demos. First of all, when you deploy to AKS, the normal flow is you do CI, you create a Docker image, you push the Docker image on the registry, and then you deploy the image. So for my experience, if you build a .NET or .NET Core application or microservice, even though you can do the build directly in the build of the image, it's probably preferable doing the the CI part, so all the build before, and just taking those artifacts and create the image with the artifacts. So this is for a number of reasons: for debugging, for logging, for speed and performances, and you have full control on a proper build, and then you just create all the image from there. This is not related to Azure DevOps, but remember, whenever you deploy to Kubernetes, to set up the proper update strategy. You know, Kubernetes have a different update strategy you can use. You can use rolling update, you can use like in-place update. Remember to set it up correctly, because if not, whenever you trigger the deploy, if it's not the correct one, you may have downtime in production, and you may not want that. Another thing is that if you decide to use the Azure Container Registry for hosting your images, remember that you need to somehow provide authorization for that. This is not only for Azure Container Registry, this is also for other private registry, but for Azure Container Registry, we have a good thing that is the one at the bottom. So you can do normally using the Kubernetes secrets, and that works for any private registry you have. Or you can use the built-in service principal. So whenever you create an AKS cluster in Azure, we create for you something called service principal, that is basically the identity with the authorization that your clustering is running on. You can assign with the script that is contained in that links, the same service principal, the permission to access the Azure Container Registry. So basically, when you deploy your image, you don't even need to pass the the credentials. Everything runs in the same service principal, and it's fully secure because both components are on Azure. There's no leaking of credentials. There's no permission issues. Yeah. In this case, it is the container credentials, so it's related to the pipeline. Sorry, the container registry credentials. Another thing is that most of the time you want to push to a registry an image that has multiple tags. And normally you have at least 2 tags. One is the version and one is the latest, right? So you can do in two ways. My way is the first bullet. So when you do that in Azure DevOps, you need to create multiple Docker push tasks, one for each tag you want to push. Or you can do the last one, the other one, which is, I will show you later in the demo, but you remove the tag definition from the task itself, and that will make the Docker push command pushing all the tags you have for that image to the registry. My preferred one is the first one because I have, in this case, as Stephen mentioned, I have full control on what goes to my container registry. If I use the other one, every tag will be pushed, maybe even tags that I don't want to push. And with Azure DevOps, we support multiple ways to deploy to Kubernetes. In my demo, I have the first one, is the classical kubectl. So you have some YAML files, you apply that files into your Azure pipeline, and you deploy with that. Or we fully support also Helm. I don't have it in my demo. I'm not a huge fan of Helm, but I know it's a very popular tool for deploying containers in Kubernetes. So we fully support that. And instead of using the deploy to Kubernetes release task, you will use the installer for Helm if you need it, and the package and deploy Helm chart for actually deploying your artifacts to the AKS cluster. Any question for that? Maybe it will be more clear during the demo. For Azure Function, it's much easier. You'll see in the demo is like 2 minutes demo because it's really easy to use. First of all, if you need to create a CI definition, don't do it from scratch. Don't do it like step by step. We have a template. It's called C#. Actually, it's not C# function. It's C#.NET Framework function. I forgot a piece. That creates all the build stuff for you. Or you can use, if it's not in C# or not in .NET Framework, you can use the language specific. We support all the languages as we mentioned before. Remember that as last step of the build, last step of the CI, you need to publish the artifact. You can publish the artifact in whatever file share you have, or you can leverage Azure DevOps for saving your artifacts that then the CD pipeline will take and will deploy. For the deploy, remember to use the Azure App Service deployment. At the end of the day, even Azure Functions somehow relies on the Azure App Service foundations. So in the Azure App Service deployment task, there is a selection for the kind of app you're going to deploy, and one of those is Function App. And this is not related to deployment, but every time I talk about Azure Function, I emphasize this. Whenever you create an Azure function, remember or don't forget about the host.json file. The host.json file is the file that actually controls the behaviors of your function. Is in there that, for example, you set the limits for the scale. As I mentioned before, if you don't set limits, we scale indefinitely, forever. If you have 1 million requests, we scale 1 million instances. You may want that. I mean, if you want to reply or to respond to your load almost real time, that's what you want to do. But you may not want that. So be careful. This is just one of the things that you can do in a host.json file. Anything on that? Any question? If not, I'll jump into the demo.
Till what point is there any limitation
For what?
for the function scaling?
So it's not a matter of scaling. Azure Function billing is paid by second, but there's like 1 million execution for free or something like that. Now I don't remember exactly. But it's for small projects. You're probably I have a few projects myself that I use Azure Function, and so far I'm not paying anything. Our small projects I'm not heavily used. We have, for example, in US a bank that does 11 million execution per day. So in that case, of course, I don't know how much they are paying. They are paying something. But for small projects, if you don't have a lot of execution, it's basically free.
Function-based services is more like nano services, right?
Yes, exactly.
More
So
than the
with the way normally we, but not only we, position serverless is that there's a monolithic, there's microservice that normally runs on containers, and there's nano service, which is basically normally serverless, and function is for that. So let's jump into the demo. The first part is a deployment to AKS. This is a real project I'm working on. It's a project that I work on in the spare time that I actually don't have. It's in for helping the Red Cross in Italy with their portal they have, and it's running on AKS. So as you can see, the Docker file, if you're familiar with Docker, is almost empty, right? I just say I want this container. I set few parameters, and basically everything is done in here. And why is like that? Is because, as I mentioned before, all the build, all the compilation, all the stuff is done before. It's not done in the Docker file itself. It's much easier. Remember this out folder is the folder where my artifacts are actually published by my build tasks, and they are just copied over in the up folder in my container. That's everything I do in the Docker file. I'll jump to the YAML in a while. Sorry, this is not related. So this is actually the CI part. As you can see, I have the full history of the builds. Some are not exactly happy, but yeah, I believe so. So some are manual, some are triggered by CI. If I jump into, let me first do one thing, because this takes a while. So let me go back so I can do this. This is the YAML file for deploying into Kubernetes. It's a normal YAML file as you can have in any Kubernetes cluster. I have few tags in there. I want to notice that it's 3 replicas. So if I go into my cluster and I run the get pods command, I will just make it bigger when I have the output, if I get the output. I'm sure I will have the output. There you go. So just want to show you that here I have my 3 replicas of my containers, of my pods. The reason why there's 2 containers in each pod is because I'm running sidecar containers. So one container is my application, one container is the sidecar. But I have 3 replicas. So what I want to do is changing these with 5 replicas. Don't worry, that is not the production cluster. And I'll push it. Always remember to put a meaningful command. And I'm using the Git repository in Azure DevOps, so I'm just pushing it there, and this will start the build. So if I stay here for a moment, this should be done. Yep. I should see a new build coming on. Yeah, you see here is the replica that just started. So I don't want to go in this yet. I just want to show you how the build is done. Looks like my Wi-Fi is quite slow. So as you can see in here, as I mentioned also before, I do the full pipeline for the build outside of the Docker container. So I'm just restoring the NuGet packages. Is a .NET Core application. So I'm restoring the packages. I'm building. I'm testing. I have some unit testing running against that. I do the publish. So I basically package my DLL for the ASP.NET Core application. And as output, I have output in a folder that is called out. And this is the same out I have in my Docker file. So when remember, if you do that, don't zip the published projects, because you want just to take the DLLs that you compiled and ship it over to the container. So after doing the normal compilation like any other .NET Core project, I just add the build of the image, which apart from assigning the container registry I'm going to use, I'm going to take the Docker file, that is the one I showed you before. In my case, this is taking any Docker file, but I have only one Docker file. So if you have more Docker files in your solution, just you can click on this ellipse here and select the proper one you wanna use. And as I mentioned before, my preferred solution is having one container image push for each tag. So if you see here, I'm getting 2 tags for each image, because I have one image with the build ID, and then I also have the latest tag. So in the build, what I'm doing is having here 2 push, one for the latest and one for the one with the build ID. And as I mentioned before, I'm quite lazy, so I don't want to write PowerShell for this. We have these ready-made tasks, so why not using it? And everything is already seamlessly integrated. So I log into Azure DevOps with my credential that I also use for logging in the Azure portal. So automatically here, I can select what kind of container registry, what kind of subscription my container registry is, the container registry itself, and everything is pre-populated because I log in with the same credentials. And last but not least, since my goal is deploying to Kubernetes, I need to have the YAML file. So the YAML file in this moment is residing in my source control. I don't want to. I have the possibility to access from here directly to the source control and pull the file, but it's probably not what you want to do. The seamless way to do that is, since you downloaded the source file into the build engine, is actually grabbing that from this folder, which is the folder where my file resides in my source control, and publish it using directly the Azure pipelines as file repository. So what I've done here is I compile the solution, I create the image, I push the Docker image to the registry, and I put somewhere safe the YAML file, somewhere safe that can be used by my release pipeline then to deploy. So let me go back and see if the build actually completed. Oh, it's still run. Oh, okay, it's finished now. Yeah, you see, now it's going. My CI is triggered by is a continuous integration, so it's triggered by the changes. So is my release. So when I go here, I should see, and I do, that my solution is already deploying into dev. If I go to see how my pipeline is made, differently from what Stephen showed us, I prefer having the pipeline completed in the same, multiple stage in the same pipeline. So I can deploy to dev, I can deploy to QA and to production in the same pipeline. And of course, I don't want continuous deployment in all the stages. Like right now, I'm going to deploy to dev, I'm going to deploy to QA, but I will not deploy to production now in this moment. And if you've seen before, also all the production tasks were failing because before today, just to be sure I'm not deploying to production, I remove a parameter from the production slot, so I'm trying to deploy to nothing, which of course doesn't work. Actually, for the dev environment, I'm not even having an AKS cluster. I'm just deploying to app service for WebApp for containers, which is a new service that we have in there. It's like the normal app service you have, but runs on Linux, and you can host your containers in there. I just want to show this because it's recently introduced. So to use that, you need to select the version 4 of the task. Normally, when you create that, it's in version 3 and doesn't have in here WebApp for containers. So this takes the exact same container from the exact same container registry, and instead of pushing to AKS, push it to the WebApp for containers.
Is there like a pro and con to choosing like a
So
service or?
for dev, you probably want to have something less expensive than the full Kubernetes cluster. Anyway, for AKS, yeah, you don't pay for the master nodes, but you still have at least 3 nodes. If you have a big development team, definitely you want to go for the same, or anyway for AKS cluster. But in this case, I'm the only one working on this project, so I'm working on that because save cost. So when this is done, I can decide, and I'll show you how, to deploy to the actual QA cluster. And the cluster is a Kubernetes cluster in which, if you are familiar with Kubernetes, I'm just running the kubectl apply command, passing, you can see it here, passing the YAML file that I edited before, increasing the number of replicas, right? And this is, if you remember before, I said I published the YAML file in a secure somewhere, which can be accessed by my CD process. And this is the somewhere. This is actually a system variable that you can use in your pipeline, which gives you access to the working set for the pipeline itself. So if I go back, let me see if this actually completed. Okay. So I don't know if you can see. Yeah. You see that it says approval pending. So what I've done is I set up the dev, and whenever I publish to dev, when the actual deployment is done, I need to approve before that goes to QA. If I don't approve, the deployment stops there with logging, etc., and then I can trigger another one. So if I go inside here, I can see that there's a approval pending. Clicking in there, I can see that what I said is that whoever user in this team, which is basically a group inside this organization, can approve. So I'm going to approve that.
Is this for the dev or the QA?
Sorry, this is for passing from dev to QA. In this case, it's a post-deployment approval, which means that normally you want to verify what you have deployed in dev, and if it's okay, you then move to QA. How I did that? Going back to the pipeline definition. If you see here, there are those things which are, it's not here, for example. This with the tick means that the user requests approval for proceeding. So if I click in here, I can see that I need to have the pre-deployment, the post-deployment approval, which is allowed from the Krivichenko team, which is the group that I'm allowing to. And you can set timeout, etc. In this case, I don't have gates from dev to QA, but if I go to production, which by the way is very similar to what I showed you to QA, it's just another cluster, I can see that only myself can approve to move the release from QA to production. And I actually don't have it here because I have it in the other side. On the other demo, I also have the gates. So if I go back to the pipeline again, seems like there's some network problems. But okay, so you see that I completed the deployment in dev. I completed deployment in QA. Prod is going to fail because I changed the script. So now if I go to my Kubernetes cluster, I should see 5 replicas because it's what I changed. And there we go. Now I have 5 pods running instead of 3. Okay. So, and as you see, there's 3 runnings from 6 hour because I wipe out accidentally the cluster this morning. Don't tell anyone. And the other 2 are running just from 1 minute because these are the new ones. All right. What do you mean?
So right now you're building the image, the container image.
Yeah.
Can you do it on other Azure technologies?
Absolutely, yeah. You can. So now I have an end-to-end process from the source to the deployment. But as you mentioned before, you can plug in just different modules. So for example, if you just want to have the continuous deployment part, you can take the image build the image wherever you want, as long as the image is in a container registry or in somewhere that can be accessed by this tool, then you're good to go. If it's already in a container registry, you just grab it from there, or you don't actually grab it, but you just instruct the pipeline to deploy the YAML file, the Helm file, using your container registry. If not, if you have it on a storage account or in a VM, you can grab it from there, push it in a container registry, and then deploy to Kubernetes or to anywhere else. It's also the opposite. So if you want to build the image here and then use something else for deployment, you can do it as well.
If I'm not using the DevOps yet, but I'm using build the image for my local machine and push to the Azure. But if I'm on vacation with the bad network, how can I update the code to the container?
Well, yeah. You can use you may want to use a hybrid approach. So you may have keep doing the stuff as you do, but having
It's the urgent fix.
Yeah.
I need to just update the code to the GitHub. Then how can I push to the container?
So you can do it. You can have these already set up, but maybe not using it, and you can hook the CD, taking it from GitHub, for example, instead of from Azure DevOps. So normally you do whatever you do, but you can set up these to take up your code from GitHub, and in this case maybe you can do it manually. So you can have a tag in your GitHub commit, for example, that make the CD process start, and then you go from there.
But if the network is not fast enough, how can I push the image
You don't have to push the image from your computer.
from the GitHub?
So let's say you just need to change one file in GitHub, right? You do that, and then everything happen not from your computer, but happen in there. So it's not a problem of your network. If you set up that to grab your source, build the image, push the image, and deploy, the only network requirement for you is actually changing the files on GitHub. If you don't want to use it for production, at least you can set up like an emergency pipeline, as you mentioned, in which maybe you can even access GitHub with your phone. It's not a recommended scenario, but change the file on the editor online if you have a catastrophic bug in production, right? That never happens, by the way. And then you change and you let this do. Yeah, yeah. So this is for AKS. Just a quick demo for Azure Function. I have few Azure Functions in production, but no one with HTTP trigger, so it's difficult to show if anything changed. So I just built this very stupid example for it's not stupid, it's a simple example for this purpose. So I have this Azure function in C# that basically just grab your name and say hello to your name. So if you want to see that it works, I have it here. And this should say hello there, Davide, because I passed my name to it. And indeed, this do it. So I want to change these to hello Azure DevOps plus the name. Oh, hello from Azure DevOps is better. And again, I'm pushing it to the source control with a meaningful command like changes. I hate all the developers doing that, and there's a lot of developers doing that. I'm pushing it to the source control online, and the network is very slow. So let's go to the release pipeline. Let me change. I have these in another Azure DevOps repository. And this is very, very, very simple. So all the logic is the same, but it's much, much simpler. So what I have is a release definition again, which, sorry, this is pipeline, is a build definition, which is configured for CI, and which just take the code from my Git repository and build it as a normal .NET application. So when I mentioned before, whenever you create a CI definition for Azure Function, if it's written in C#, use the template, because it creates all of this for you in 1 second. If not, you need to add 1, 2, 3, 4, 5, 6, 7 different tasks manually. And whenever I created that, I didn't have to change anything. Everything was already set up. I just saved and passed to the CD pipeline. If you want to what you see, basically just restore the packages, build the code, and publish the artifacts. As I mentioned before, this is an important step. You need to have your artifacts published, because the CD pipeline needs to take that and publish it to the Azure function. If we go to the release, again, very simple. In this case, I only have the dev environment. And this is all I needed to do. So deploy Azure Function App is actually an Azure Web Service deploy task, in which I just have to select the subscription. I just have to select the function app and the function app name. That's it. Automatically, since the pipeline starts when the CI finished, it knows already where the artifacts are. It knows everything. You just take that and publish to the function. That's it. 1 task, 7 tasks for build, 1 task for deploy, but 7 tasks for build is just 1 template, automatic. That's it. So let me see if that finished. The build is finished. The release is still in progress. Probably it's already finished. And let's see. Seems, yeah. So it already deployed. Why is still pending? Because, as I mentioned before, I have some gates. In this case, I put the gate that I need to invoke the function twice within 5 minutes, and twice it has to return 200. only then I can consider my deployment completed on the Azure DevOps. How I did that? I have it here. Gates. One type of gate you can set is invoke a REST API, but you can add as many as you want, and you can also invoke an Azure function directly. You can invoke an API. You can query the Azure Monitor alerts for seeing if you have any problem in your deployments. You can even query work items. For example, this is useful if you need to pass from QA to production. You want to do that only if you don't have any bug open on your current QA, right? So you can query if you have all the work in your work items in Azure DevOps, and if you have no bugs, then you can publish, and et cetera, et cetera. And in my case, it was just a simple get to my Azure function, passing my name as parameter. So if I go here, I should be, no, yeah. Sorry, this is not the running one. This last thing I want to show you is if I go here, I can see that the deployment is gone good, but I'm processing the post-deployment gates. The first one is successful, and I have one more in 4 minutes, which is still pending. When this will be completed, if it's successful, the whole deployment will be marked as successful. This is very useful in real production environments because you don't want to do CD with code that you don't know if it works, it doesn't work, who knows. So you can put some boundaries. It's good to have CD, but not too much, right? With this, I finished. I'm a little bit over time, so if you have any questions, feel free to ask. In the meantime, I will close down everything. Thank you.
Thanks, David. Thanks, Stephen. We still have something more to give you. There is swag, as I mentioned to you. Don't want to keep you too long because the air conditioning is off.